Now I want to look at the cosine parent function. In other words, the most basic cosine function, cosine of x. And there are no transformations here or anything. It's the most basic cosine function. And here, x is an angle in rads, okay? Now we're going to use rads so that we don't have the unit of degrees in our graph. And the way we're going to look at this is we will observe the cosine function as we rotate around the coordinate plane. We'll use that then to create an xy table, basically to help us understand the cosine function, where the y values are the cosine of the x values. And then we'll use that to graph the cosine of x function. Where the x-axis are the angle measures and y is the cosine of those angle measures. Okay, so the first place we're going to start over here in our rotation is we're going to start at the angle of 0, which is right here, giving us a terminal side on the positive x-axis, and cosine outputs the adjacent or horizontal side, so the x value is 0, the angle is 0. The cosine of 0 outputs the adjacent side or the horizontal side, which when you move to the right one, the horizontal side is positive 1, divided by assuming a hypotenuse of length 1 as well. So that reduces to 1. So whenever x is 0 on the graph of the cosine function, it outputs the y value of 1. And then let's rotate all the way up here to pi over 2, another easy angle to work with. If we look at pi over 2, cosine gives us the adjacent or horizontal side is 0 divided by a hypotenuse of 1, reduces to 0. So at pi over 2, cosine outputs 0. Now let's observe what happens if we look at angles in between as we rotate from 0 to pi over 2. I'll do that in red. So if I look at this angle and consider the reference triangle with a hypotenuse of 1, cosine is going to output this length here. You can see that length is shorter than 1. Okay, that's the distance we are from the origin here. That's shorter than our original length of 1. So as I rotate off of 0, immediately my cosine y value, my cosine of x function, starts dropping in value, and it drops rapidly, right? I draw another reference triangle here. You can see the adjacent side in this case is even shorter, and as I get close to pi over 2, the adjacent or horizontal side gets even shorter. So it starts decreasing rapidly. My y values, my cosine function starts decreasing and speeds up as I get to pi over 2. I think I said that wrong before. Sorry about that. The horizontal sides here decrease slowly, and then they start speeding up around the halfway point, right? They start speeding up and decreasing really rapidly. So we see that behavior over here. Now I'm going to look at an angle of pi. The cosine of pi is the horizontal side -1 divided by a hypotenuse of 1, if you will, which reduces to -1. So on my graph of the cosine function at pi, my y value is -1 down here. And what's happening here is exactly the reverse of the other rotation. Your horizontal side here decreases from 0 to -1 rapidly until it starts getting closer to pi, and then it slows down. So it starts leveling off. It's going down, getting more negative, but then it slows down as it gets to -1, and that's the end of growing in the negative direction. Now let's look at 3 pi over 2. So I need to know the cosine of 3 pi over 2. Here the horizontal side is 0 divided by a hypotenuse of 1, gives us 0 again. So my function comes back to 0, and you can probably guess the same pattern as all the other rotations. Okay? And then finally, getting back up here to 0, which is coterminal with 2 pi, we'll want to consider that as 2 pi now. I'm back to the same horizontal side I had before, positive 1 over hypotenuse of 1, which is 1. So I'm back to where I started and following the same pattern of the speed at which it changes. Okay, so some important points here. At the tops and bottoms, it starts to level out. It's not a sharp point. It doesn't grow like this and stop suddenly like that. It levels out as it gets to the top or the bottom. Okay, so that's important. But hopefully you can recognize if I did rotate again up to this point, which now we'd call this angle, call 5 pi over 2, I'm going to end up back down at 0. And my graph starts to repeat the exact same pattern as I rotate through the plane. And even if I go in the negative direction, it repeats and we get this infinite wave. Alright? So that's what we get when we graph the cosine function. So talking about some language that goes with this is what we call a periodic function because it repeats itself infinitely. And so what we do is we look at one complete cycle. So that's called a period. This portion of the cosine function is the portion that repeats forever. I could pick that up and draw it again and it repeats again, or even in this direction. Okay? So the period is one cycle length. And so if you look at this, you have to measure the x values. It starts at 0 and goes to 2 pi, so that is a length of 2 pi. That's the length of the period for the parent cosine function. This function oscillates. It goes up to 1, down to -1, back and forth forever. And so that gives us this value in the middle called the average value, which here is the y value of 0. That's the middle y value. Okay? And last, we have what's called the amplitude. The amplitude is how far the function will deviate from its average value. In this case, it goes one above and one below the average value. So we say the amplitude equals 1 because it's that distance that it deviates from the average value. So that's the cosine parent function. The general idea, so this is a general description now. The cosine function starts at 1, starts and of course ends at 1 if you're looking at one cycle. In the middle hits -1, and what I like to call, so I've got the beginning, I've got the end, and I've got the middle. So all that's left is to talk about the middle of the middle, right? So I like to call those the quarters. Those are at a quarter of the way through, 1/4 and 3/4. That's what I usually call it in my classes, my seated classes. At the quarters, it hits 0. Okay? So that's kind of important to know. So if you want to construct the cosine graph, start at 1, end at 1. In the middle, you're at -1. And at the quarters, halfway between those, you're at 0. And then connect it with a smooth curve that kind of levels off at the tops and bottoms. Alright? So that is the cosine parent function.